Modernage MCQs, Physics second year, unit number 19, Atomic Physics, part 4. In an excited atom, the total energy is E. What is the kinetic energy? Option A, plus 2E, option B, minus 2E, option C, minus E, option D, plus E. The key is minus E. Therefore, the correct option is C. Reason, the total energy of the electron E is equal to minus K E squared divided by 2R, and the kinetic energy of the electron is Ke is equal to Ke squared divided by 2R, which can be written as minus into minus Ke squared divided by 2R, putting the value of E, the kinetic energy is equal to minus E. Hence, the kinetic energy of the electron is minus E. The ground state energy of an electron of hydrogen atom is minus 13.6 electron volt. What is the potential energy of the electron? Option A, minus 27.2 electron volts. Option B, plus 27.2 electron volts. Option C, minus 13.6 electron volts. Option D, plus 13.6 electron volts. The key is minus 27.2 electron volts. Therefore, the correct option is A. Reason, the total energy of electron is equal to minus K squared divided by 2R, and the potential energy of the electron is equal to minus Ke squared divided by or multiplying and dividing by 2, we get 2 into minus Ke squared divided by 2R, which is equal to 2E. Therefore, the potential energy is equal to 2 into minus 13.6 electron volt, which is equal to minus 27.2 electron volts. Hence, the potential energy of the electron is minus 27.2 electron volts. An electron is accelerated in an X-ray tube applying a potential difference of V0 if it loses all energy in single collision with the electron of target, then the wavelength emitted by X-rays will be option A, He divided by C V0, option B, Hc divided by E V0, option C, EV naught divided by HC. Option D, CV naught divided by HE. The key is HC divided by EV naught. Therefore, the correct option is B. Reason, the energy of the electron is kinetic energy equal to the work done, which is E into V naught, by the accelerating voltage, potential difference V naught. In a single collision, all the energy lost by electron is radiated in a photon, which is Hf is equal to Hc divided by lambda. Therefore, Ev naught is equal to Hc divided by lambda, or lambda is equal to Hc divided by Ev naught. Hence, the wavelength of emitted X-rays will be Hc divided by Ev naught. What is the ratio of energies of an electron in first to second orbits of hydrogen atom? Option A, 4 to 1. Option B, 1 to 4. Option C, 9 to 1. Option D, 1 to 9. D, 4 to 1. Therefore, the correct option is A. Reason, the energy of an electron in the nth orbit of hydrogen atom is En is equal to minus E naught divided by n square, where E naught is equal to 13.6 electron volt. For first orbit, the energy is E1 is equal to minus E naught divided by 1, which is equal to minus E naught. And for second orbit, is E2 is equal to E naught divided by 2 square, which is equal to E naught divided by 4. Therefore, the ratio is E1 to E2, which is equal to minus E naught divided by minus E naught divided by 4, or E1 to E2 is equal to 4 to 1. Hence, the ratio of energies of an electron in first to second orbit of a hydrogen atom is 4 to 1. The energy of X-ray increases by increasing option A, area of the target of X-ray tube, Option B, area of the cathode of X-ray tube. Option C, current in filament of X-ray tube. Option D, voltage across cathode and torque. Key is voltage across cathode and torque. Therefore, the correct option is D. Reason, the energy of X-ray depends on the kinetic energy of electron. The kinetic energy of electron increases with the increase in voltage because the work done on the electron is V into Q, which is equal to V into E, where Q is equal to E, the charge of the electron. Therefore, the energy of X-ray photon is Ex is equal to HF, which is equal to the kinetic energy of the electron, and it is V into E, or Ex is proportional to V. The energy of X-ray is proportional to the potential difference implied across the cathode and anode. Hence, the energy of X-ray increases by increasing voltage across cathode and torque. What will be the magnitude of energy required to remove electron from 4-6 state of hydrogen atom? Option A 13.6 electron volt, option B 3.4 electron volts, option C 1.51 electron volts, option D 0.85 electron volts. The key is 3.4 electron volts. Therefore, the correct option is B. Reason, the electron will free if it jumps from the excited state n is equal to 2 to the state n is equal to infinity. The ionization energy is I is equal to E infinity minus E1, or Ei is equal to minus E naught divided by infinity minus E naught divided by 2 square. E naught divided by infinity is 0. Therefore, it is equal to 0 plus E naught divided by 4, which is equal to 13.6 divided by 4 electron volt, because E naught is equal to 13.6 electron volts, which is equal to 3.4 electron volts, because E naught is equal to 3.4 electron volts. Hence, the energy required to remove the electron is 3.4 electron volts. The characteristic X-rays depends on option A, current in filament, option B, size of the target, option C, nature of the target, option D, area of the target. The key is nature of the target. Therefore, the correct option is C. Reason, the energy of K, L, M, and shells depend on the nature of material used to make target. For different materials, K, L, M, and shells have different energies. Therefore, the transitions K alpha, K beta, K gamma, L alpha, and L beta of X's have different energies. This property of X's is used in material testing. Hence, characteristic X's depend on the nature of the target. When hydrogen atom jumps from first excited state to ground state, a photon is emitted carrying energy. Option A 13.6 electron volt, option B 12.1 electron volt, option C 10.2 electron volt, option D 3.4 electron volts. The key is 10.2 electron volts. Therefore, the correct option is C. Reason, according to En is equal to minus E naught divided by n square. The energy of an electron in the ground state is E1 is equal to minus E naught divided by 1 square, which is equal to minus 13.6 electron volt, because E naught is equal to minus 13.6 electron volt. And in the first excited state is E2 is equal to minus E naught divided by 2 square, which is equal to minus 13.6 divided by 4, which is equal to minus 3.4 electron volt. The energy carried by photon is E photon is equal to E2 minus E1, which is minus 3.4 minus 13.6 electron volt, which is equal to 10.2 electron volts. Hence, the energy carried by emitted photon is 10.2 electron volts. An atom jumps to ground state from first excited state. What will be the number of transitions in Lyman series? Option A1, option B2, option C3, option D4. The key is 1. Therefore, the correct option is A. Reason: the quantum number of first excited state is n is equal to 2 and ground state is p is equal to 1. The electron in one jump reaches the ground state, therefore there is one transition in Lyman series. Using the equation for spectral line n is equal to n into n minus p divided by 2, the number of transition is n is equal to into 2 minus 1 divided by 2 is equal to 1, where n is the quantum number of higher orbits and p is the quantum number of lower orbits. Hence, the number of transitions in Lyman series is 1.